Assalamualaikum warahmatullahi wabarakatuh, Mr. Fauzi. My name is Muhammad Fahmi bin Muhammad Inas, and in this presentation, I am presenting the introduction. So first, let's see what is fiber optic. So fiber optic has brought telecommunication industry to a next level. So optical communication have made it possible to make telecommunication links over much larger distance with much lower loss. And thirdly, fiber optical communication have allowed much higher data rates to be transferred. So next we go to optical transmission. What is optical transmission? Optical transmission is a measurement of light through a medium that is transmitted, and due to absorption of the medium, light may be attenuated or it may be dispersed from the beam. So this brings us to the dispersion. So next I will pass to my friend Azik to explain what is dispersion.
Okay, thank you Fahmi. So now I will explain about the dispersion. So dispersion is the spreading of light pulse as it travels down the length of an optical fiber. So dispersion limits the bandwidth and information carrying capacity of a fiber. Then the bit rates must be low enough to ensure that pulses are further apart, and therefore the greater dispersion can be tolerated. There are three main types of dispersion in fiber, which modal dispersion, material dispersion, and waveguide dispersion. I will explain two dispersion in the assignment. So the first one is material dispersion. This material dispersion is a dispersion of delay time caused by the change in the reflective index of the glass material in line with the change in signal frequency or wavelength. So the second is waveguide dispersion. This waveguide dispersion is the most important in single mode fibers. Occurs because optical energy travels with slightly different reflective indices in both the core and cladding. So that's all for me. I'll pass to Fauzan for the methodology. Thank you very much.
Thank you, Aziz. My name is Raja Ahmad Fauzan Shahab bin Raja Ahmad Farid, and today I'm going to be explaining about the project methodology for this project. In this part, it outlined the carried out research of the working process of the project, basically its methodology in designing the simulation circuit that portrays the dispersion in an optical transmission system, generally in an optical fiber. The proposed project will be two circuits with different parameters that portray two different dispersions occurred in an optical transmission system. The use of two simulation circuits in this project is to observe and analyze the comparisons of the outputs between two different types of dispersion. This project will be solely done and simulated using a simulation software called OptiSystem. So basically, this is the construction design of the chromatic dispersion, and this is the construction design for the model dispersion. That's it for me, and I'm going to pass it to Afif.
Assalamualaikum. My name is Muhammad Afif bin Nasaruddin, and I would like to explain about the simulation circuits of schematic dispersion and the model dispersion. Two types of optical transmission dispersions were stimulated to compare the performance of both optical transmission systems, and this was the chromatic dispersion of optical transmission system. Now run the calculation until finish. Okay, and then click the optical power meter to show the power at the transmitter and at the receiver. But the power at the transmitter was negative 6.218 dBm, and while the power at the receiver was negative 6.860 dBm. Power in dBm was converted using the watt value by the formula of 10 times log to the power base of 10 times the power. After that, click at the Burr analyzer to obtain the Burr analysis. As you can see, the eye diagram was sharp and not degraded. The Q factor was 10. The minimum Burr was 7.278 times 10 to the power of negative 4. Is equivalent to the 5.24 exponential negative 0.025, and lastly the threshold was 0.0389 or 5.776 exponential negative 0.05. Okay, next, this is the model dispersion, or known as the pulse spreading dispersion of optical transmission system. Hence, we can see that the optical power meter at the transmitter and at the connector were same, which was negative 5.652 dBm. But at the end of the parabolic index multi-mode fiber was different, which was negative 100 dBm. Okay, next, the Berg analyzer showed the eye diagram or the Berg analysis and showed a degradation of the eye diagram and only had minimum Berg, which was 1. Okay, that is all from me. Thank you.
To design first optical fiber topology, wavelength of 1550 nanometer, dispersion of 1920, power of negative 3 dBm, bit rate 10 GB, gain 20 dB and length 50 km is used. For this circuit, two optical power meter is placed on Mach Zehnder modulator and decimal optical filter to measure the total power. For this circuit, total power around 238.87 watt and around negative 6.3181 dBm and 206.08 watt and negative 6.8602 dBm is measured. For BER analysis, a good reading of Q factor 10.2264, minimum BER 5.2402, eyesight 0.000312904, 3 hole 5.7769 and decision inst 0.609375 is recorded. For circuit 2, wavelength 1550 nanometer, power negative dBm, insertion loss 70 dB, bit rate 10 GB and length 50 km is used. For this circuit, 3 optical power meter is used. The optical power meter is placed on spectacle optical transmitter, special connector and parabolic index multimeter fiber. Optical power meter record reading 272.129 watt, 272.129 watt and 24.263 watt. For BER analysis, max Q factor, eye heights, threshold and decision instant reading shows 0 while minimum BER shows 1.
Hi, my name is Amir Rasulihin. So I will present the conclusion for this assignment. Fiber optic technology is the new trend in communication industry and is steadily and effectively replacing the copper wire system for transmission of signal. The new development in the networking industry is fiber optic technology, which continuously and efficiently substitute the copper wire infrastructure for signal transference. The use of smaller diameter of the core, which permit less modes, will prevent dispersion, and the use of single mode fiber also does not allow model dispersion. Based on the dispersion simulation, as the fiber length increase, the efficiency factor decrease when the input capability decrease in BER. The improvement in the input bit rate on the other side decrease the dispersion quality factor. In the case of increased fiber volume, the quality factor decrease as the BER decrease as the input power increase. Simulation of the dispersion proved that the performance of chromatic dispersion is better than model dispersion. So that's all from our group. Thank you.